Welcome to geometry number 4. Today we're going to learn about reflection. So by the end of this lesson, you should be able to identify, describe, and represent the position of a shape following a reflection, and you should be able to use accurate mathematical language and understand the shape has not changed. Remember, a reflection is a rigid motion. That means its size and its shape do not change. So first I'm going to start with giving you some examples of reflection in other fields. So here we have in art, you might be familiar with this. We have a line of reflection and you can see that that bird is drawn and its shadow is using that line of reflection. Here's an example of a reflection line in photography. So here's our horizon line and you can see that they've drawn a trapezoid here, kind of a trapezoidal type shape for us. And you can see that each point on this trapezoidal shape is a mirror image. So I go into the reflection line and then I come back out and I end up with that point here. So it's a mountain, but they've kind of shown you what that would look like. Here's an example of many lines of symmetry or reflection. So when I look at this star, I can see all these different dotted lines and imagine that that star could be folded over one of those lines. You might be familiar with using a heart and folding a piece of paper and cutting out half of the heart, or a butterfly or something like that. And then I love this one. Here's reflection in game design. So on the computer, you can do so much with reflection. And you can see if you look at these two images, they're not exactly the same, even though they're reflected. And this was a post I found online where they're struggling using the process to make it be a perfect reflection. So they're seeking support. But they've got the concept where the person has flipped, but they're not quite there. And you probably, if you've done any work with photography, you can flip your image. This would be a reflection. So now we're going to just make sure you know that vocabulary we'll be talking about. You're going to talk about reflection, your coordinate grid. We've already done some practice making sure we can plot points. We've recently reviewed that x-axis and our y-axis over here. The mirror line is that reflection line. We'll be pointing that out today. Congruent is simply another word for them being equal, and it is an equal sign with a little squiggle on top. So we'll start talking about that. The word vertex should be familiar to you. So we're talking about if we have a shape, we've got these a vertex, or vertices would be the plural. Shape, I think you know. Units and position in space. So let's get going. Reflecting shapes, we have to start with a shape, our original shape or our pre-image, and then our new shape, our reflected shape or our image. And here's our mirror line. That's what we fold it over. So everything will be the same distance from that mirror line. You go in and you go back out. So we're going to start with just looking at a shape. Notice that I have labeled everything A, B, C, D, E, and F. Every vertex is labeled. And our mirror line is shown in that dotted line. And now we're going to walk through the steps of reflecting. So the first thing you would do is you would go in. And if we say we're reflecting over that line, we need to bounce our 4 steps into the line. And you can imagine you're going to need to bounce the same 4 steps out. So here we have it. And you put your point at that new spot. And remember, when we create a new shape or that image of the shape, it's going to be primed. So when we draw all of these, now I've shown you each one going in and then going out and going in and then going out the same amount. So I've plotted all of those points. I haven't connected them yet. But when I connect them, I want to make sure that my B, when it goes in and then comes out, is now called B primed. So remember, this is my pre-image, and this is my image, and it's primed. It's worth noting right now that we can do this as many times as we want. And if we were to do this again, my B primed would have to be B double primed. And we'll talk more about that. So now we're going to go and look at lengths and angles. So here is our quadrilateral. So quadrilateral just means four-sided figure. And we have W, X, Y, Z. And they say that it is a reflection of A, B, C, D. So sometimes we can use different letters instead of primes. So here we have our reflecting line or our folding line, and they give you some lengths. So this is where you see your line segments and your lengths. So AB, they told you is 4 centimeters. And they told you that BC is 2 centimeters. And I'm going to label all of these. CD is 3 centimeters. And DA or AD, you can call it either, is 2 centimeters. When we learn to name these, we actually put a little line on the top of them. You'll notice they don't have that. Then remember, this M means the measure of angle A. So I'm going to go up to A, and I'm going to use blue now. A would be this little arc right here, and we know that's 82 degrees. And B would be this little arc right here, and we know it's 59 degrees. I'm not going to label them all because it gets a little crowded. They ask me to predict the lengths of the sides and measures of the angles in W, X, Y, Z and explain your reasoning. So I'm going to start with explaining. And I want to use this vocab word that we've had. This is a rigid motion. That means its size and shape stay the same. I think you can tell that. And you should be able to tell what corresponds with what. So when it folds, I'm going to use green now, and I'm going to start with my AB being 4 centimeters and ask you if you can tell what you think corresponds. And I hope you see that WX corresponds. So my WX is going to also be 4 centimeters. My XY, I need to figure out what it corresponds with. So my XY is right here. And I hope you can see that that corresponds with my BC. So that's 2 centimeters. I'm going to show the angles now, and I'll say the measure of angle W, and it's marked right here. That would correspond with my measure of angle A, so it would be 82 degrees. My measure of angle X is going to correspond with my measure of angle B, so it'd be 59 degrees. Consider pausing this video and answering the other two. So CD is right here, so it would line up with YZ or ZY, so that would be 3 centimeters. And ZW would be here, and that would line up with DA or AD, so it'd be 2 centimeters. And now measure of angle C is the Y, so that would be 129. And measure of angle D is the 90, so measure of angle Z has to be 90. One thing in case you don't remember from earlier grades, that 82, 59, 129, and 90 should add up to 360 degrees because a quadrilateral has 360 degrees. Now I want to talk about lines of reflection, and this might feel new to you. It probably is new to you. So I'm going to ask us to plot these points. And remember, it's always X and then Y. And I think black is probably the best choice for color for me. So 5, 0 would be 1, 2, 3, 4, 5 to the right, and nothing for the Y. So I'll put that here. 5, -3 would still be 5 to the right for my X, and it would be down 3. And 5, 4 would still be 5 to the right for my X, and it would be up 4. I hope you see by seeing those 3 points that every single point that has an X of 5 is going to go on this line. So I'm going to fill those in, and you might be looking at this little X equals A and say, I think that reflecting line is that vertical line. And you would be right that any line that has an X coordinate of a certain number is going to follow this path. In this case, it's X equals 5. we routinely say x equals a, meaning it can be any number. So if I were to plot the points -3, 0, -3, 2, and -3, 5, all the x's are -3. So you could plot them and you would say, oh, that would be this line of symmetry or this line of reflection, and I would call it x equals -3. So that's one line of reflection we could look at as an x equals something. It's a vertical line. Another line of reflection is when the y's are all the same. So maybe predict right now what you would expect as I plot these points. So -2, 4, 4, 4, and 0, 4. Remember, it's x, then y. So your x, you stay put, and your y, you go up. If you predicted a horizontal line, you're right. So this is your x equals 4. Oh, I just misspoke there. I said x equals 4, but I'm wrong, right? It's a horizontal line. It's y equals 4. Each time my y is 4, so it's y equals 4. Any horizontal line is going to have the same y coordinate. Now that's important for us as we do some more examples. So here we have an image. This is called a kite. You can see it looks like a kite you would fly in the air. And it says that ABCD has been reflected across a line to produce a new one called A primed, B primed, C primed, D prime. It asks us to draw the line of reflection, and it asks what the equation is for the line of reflection. So I'm going to zoom in, and I need to predict exactly what the line is that it's folded over to make the new one. And I hope you can tell that it would have to be a vertical line, and it's got to be somewhere in between here. So I'm going to count this 1, 2, 3, 4, 5, 6. And if the whole distance is 3, then or 6, then I know half the distance would be 3. So I'll recount this 1, 2, 3. There's half my distance. So my line of reflection would be here. That's the first thing. It says identify your line of reflection, draw it. So I drew it. Now it says, what is the equation? So with the equation, we have to say to ourselves, this is a vertical line. And what I know about this is that every single time, which coordinate stays the same? Is it my x or my y? And remember, it always goes x comma y. So I could pick any point, and I'm just going to pick this one. And I would say that that point is -2 and -3. So my x coordinate is -2. And I urge you to look at that and say, do you agree that every x coordinate here is -2? I'm going to say yes. And your equation for your line would be x equals -2. There we go. That's our line of reflection. Now we've been given a figure. Triangle ABC has been plotted, and they've asked us to reflect it across the y-axis. So I'm going to draw the y-axis, even though it's on here, and remind myself that is a vertical line. And that happens to be the vertical line x equals 0, but instead we call it the y-axis. So remember, when we reflect, we draw in equal numbers. So I'm going to go 2 in for C, and then 2 out will be C primed. 5 in for A, and 5 out will be A primed. And it looks to me like 7 in for B and 7 out. And this one I'm going to shortcut, and because I can tell without bouncing, I'm going to do that for B primed. If we've done it correctly, we should see a figure that has the same size and the same shape. If I had a ruler, it'd be perfect, but I don't. So now it asks me what the vertices are. There's that plural of vertex. So I can simply count. And B prime looks to me like it is negative 7, 3. So negative 7 comma 3. And I want you to look for pattern here. C primed would be negative 2, 4. And A primed would be negative 5, 8. So it asks you to connect, which I've done, and it says, what is the relationship between these segments and the y-axis, the line of reflection? That's an interesting question. The thing that I notice is that the only thing that's changed is my 5 turns into negative 5. My 7 turns into negative 7. My 2 turns into negative 2. So the rule when we reflect over the y-axis is that my x, comma y, whatever my x is turns to be the opposite, or negative x would be how I could say that, and my y remains the same. This is something, if you'd like to, you could memorize, and it might help you as you do your reflective learning. Now, preparing you for your assignment in Delta Math, they will give you a chance to reflect over things other than the axis. You'll have to plot the points, but I'm going to show you the thinking. So here's our figure, and now they ask you to reflect it over this blue line. So you have to bounce in 4, and you have to know you're bouncing out 4, and you'd plot that on the computer. Here, you know you're bouncing in 1, 2, 3, 4, 5, 6, 7, and you're bouncing out 1, 2, 3, 4, 5. Let's see, maybe I counted wrong. 1, 2, 3, 4, 5, 6, 7, 8, right? Because I've got to reflect it over that line, and I'll bounce out 1, 2, 3, 4, 5, 6, 7, 8. And then the same here, you're going in 2, and you would go out 2. So you'll connect your points on the computer. You won't draw this on paper, and you'll have something that looks the same upside down. It's a rigid motion, so the shape should be the same shape and the same size. You'll also see it when it's reflected over the line x equals 1. That's that vertical line, and you'll follow that same process. Notice it says you may click a plotted point to delete it in case you make a mistake on the computer. Now there are times where you're going to be asked, and I will tell you, this is the question on Delta Math. I'll be giving you graph paper because you might need it. I've put graph paper here for myself. It says point S is located at 1, 1. So I'm going to draw that. Here's point S. And it says point S is reflected to make the point S primed. It says it's reflected over the y-axis. So the y-axis is going to be drawn in red. And what I do is I bounce in 1 and bounce out 1, and I'll have S primed. We talked about what would happen on that, and I mentioned you may want to memorize this because 1, 1 simply becomes negative 1, 1. My x, y turned into negative x, comma, y. So my new point is negative 1, 1. So if you have that, you might be someone who says, I don't need that graph paper. I can figure this out without it. But you'll have it if you need it. And then I mentioned that we could do 2 reflections, in which case it would turn into double primed. So notice the double primed here. And I'm going to show our steps. So U is 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, up. So there's my U. And it says it's reflected over the x-axis. So I'll draw the x-axis to create the point U primed. So remember, you bounce in 3 and you bounce out 3. I'm thinking of my rabbit right now with bouncing. So here we go. And when you bounce in and you bounce out, you started with the point 6, 3. And now you would have the point 6, negative 3. So those of you that like to memorize and look for patterns, this pattern, when it's reflected over the x-axis, is your xy turns into your x staying the same and your y flipping to the opposite. So that gives you your U primed, but that's not what they ask for. Now they ask you to reflect it over the y-axis for U double primed. So I'm going to draw that in blue. And I actually think this is really fun because you get to do multiple steps. And I'm going to bounce in 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And now I can count my spot, and I would say U double primed would be -6, -3. So when I do that, I end up with U double primed being -6, -3. Notice when I did that across the X and the Y that my original X and my original Y flipped. They're both negative now. So this is if we have two reflections. This you may want graph paper for. Be ready for it. So now, recapping, you know that shapes can be reflected across a mirror line. You know the shape stays the same, but it's flipped as if it's folded over the opposite side of a line. So again, just closing, here's our mirror line, and I'll think, okay, I'm drawing a butterfly, and I would imagine that this is folded, and we have the same shape on the other side.